Hello, good afternoon, everyone. First of all, thank you very much for being here today. It's Saturday, it's afternoon, thank you very much. And also a special thanks to the Maritime Hacking Village for having us today. So, well, let's move on to the next thing. Let's talk about agenda today for the next 30 minutes, what you can expect from me and from Vlatko. First of all, why maritime and cybersecurity are so important for us and so interesting. Then the scope of this presentation. Then how we identified organizations. We will present some brief summary of the findings with our experiments, and then we'll move on to the technical part under the hood. My colleague and boss, Vlatko Kost, will introduce about architecture, tools, and all the lessons learned from our experience. Finally, we will release our tool, and we'll have a section for questions and answers. Before we start, we'd like to introduce ourselves. He said, ladies first, so okay then. My name is MJ, and I'm a threat and security intelligence analyst. I'm passionate about the maritime and threat actors, tactics, techniques, procedures, techniques, everything. And I've been focusing on that over the past few years. And apart from intelligence, I'm passionate about working out, flying the world, and my favorite spot in the world, which is New York City. And please, Vlatko, Kost, introduce yourself.
Yeah, hi, everyone. I'm VP of Research, 20 years of experience in cybersecurity in different industries, but also I was in previous life like ex-threat team leader, CTO, and so on. But currently I'm really obsessed with MCP, plumbing, and automation. So if something takes manually 1 hour, then I usually take 1 day to automate it, right? Standard way. Also in previous life, I was very fan of doing like a martial art, but considering my body shape now, I'm more into sumo wrestling. But even that watching, you know. So yeah, I will let MJ talk, and then later I will join.
Awesome, thanks. Let's put things straight. What can we expect from this presentation? This is not a talk about active scanning. It's just absolutely passive. It's not thought to be shaming or exposing anybody. No, not at all. And it's not a deep dive into maritime protocols. However, this talk is about digital hygiene. It's about passive approach. It's about anonymization. That's why we're not exposing anybody. And also a summarization, having the big picture of what we have found, mapping the waters. And it's a novel approach, I have to say. Vlatko and I, we found it very interesting because it is the first time that we see that open source intelligence plus automation plus large language models are applied, and we have got serious insights and having this big picture of vulnerabilities into the maritime industry. Why the maritime was the focus of our investigation? Well, as you know, maritime is critical for global infrastructure. 90% of the global trade moves over water, and ports, shipping lines, oil tankers, offshore platforms are the arteries of global commerce. Disruptions here can ripple across supply chains, energy, even national security. And this industry has experienced a very fast digitization, and it has been done so for laying on legacy foundations like legacy IT stacks, forgotten domains, and something that I find especially important here, which is that it's been found on vendor-controlled infrastructure. Also, this industry have been seen like air gaps, but nowadays, because of this digitization, it has been more and more faced. There are like email, corporate IT, cloud assets that are internet facing, so they're public. Attackers have noticed. I'm sure that you remember the NotPetya attack back in 2017, and you're also well aware of the latest ransomware incidents that many ports have suffered recently. And there is a key point here as well. It's the fact that it's been under-investigated from an OSINT point of view. from an OSINT perspective. You know, security researchers and open source intelligence analysts, we have been focused on financial industry, health industry, big tech, energy. But maritime has been ignored, so to speak, and it has. Once we have got into it, it has revealed high impact discoveries. I like to say that this is like a universe where there are many organizations. It's not only shipping, but subsidiaries, global staff, third-party contractors, satellite, mixed environments. So it is a great case study for digital hygiene. And TLDR, if you care about infrastructure, I think this industry is one of the most connected, exposed, and under-measured digital ecosystems in the world. So I don't like to talk about maritime industry rather than maritime ecosystem. And if we want to analyze the full attack surface, which is the purpose of this exercise we've done, it's not only ship operators, but it's also ship managers, it's also ports, port terminal infrastructure, it's also government is involved, regulators, enforcement, flag states, PSC, port security controls, also the private sector, maritime service providers like shipbuilders, repair yards, classification societies, and there is also a bunch of other entities that are there like cargo, logistics, crewing, navigation and communications, and so on and so forth. Switching gears, I want to explain you how we started this and how we built up our mapping. We gathered a list of organizations. We relied on search registers, official ones, trusted ones, like the Alpha Liner list. And also we identified the protocols we wanted to search. For specific of the maritime, but not only specific of the maritime, a bit general, but the ones we wanted to share. And then we asked LLM to construct the list. And here on the right-hand side, you can see an example of query that we launched. So, results. Ocean of vulnerabilities. If we focus, for example, on email intelligence, we found that 41% of the whole number of organizations, exactly, they had no DMARC policy, which made them susceptible to suffer from spoofing. 98% of the sample, they had no DNSSEC, which, they were susceptible or at risk of DNS poisoning, which that showed a lower maturity level if we compare that to other industries. In the middle, you can see the 28% of the results with no SPF records, susceptible or at risk of sender forgery, but this number is not as low as in other industries. It's more or less balanced. What did we find? I want to show you an example, anonymized, of what we found. 3 examples. We found a major Asian port authority that had a PHP programming language that had a very, very outdated version. End of life was of 2017, meaning that from then on it has not been supported. We also found somewhere else in the world, in Europe, an European shipping corporation that had more than 15 MySQL databases exposed. And moving to the other hemisphere, here in North America, we found an American port that had more than 24 critical CVEs exposed. Now, I would like to show you an example in depth. This is the visualization of the information we got with the aid of the LLM and the indexed sources, Zoomai or Shodan, something like this. I mean, scanning index sources. And here we can see 3 things I would like to highlight. First, authentication methods. Some of them the SQL didn't have. Some of them had, but you can see the passwords and the users. For example, root, admin, user, and operator 1234, and some of those didn't even have anything. Also, the sensitivity of the exposed data. We have sensitive crew information, for example, payroll. We have bunker and fuel data. We have vessels maintenance logo, cargo manifests, vessel routes. So really, really sensitive. And the third thing I would like to highlight here is the sort of CVEs that we found. There are recent CVEs as of 2023, but you can see CVEs ranging from 2012 till 2016, which is something it is worth noting. Here, let me point out one thing. It is the fact that since it was passive, I cannot say that we cannot say this is 100% true because we couldn't double check, but it's very likely it is. Now, I want to take your attention to specific maritime systems. What we found, 3 things again. Regarding communications, GNSS and GPS systems, we found the protocol NTRIP that was widely exposed. We found multiple casters exposed in the internet, and well, as you know, these devices, or this technology, this protocol enables GGPS systems to be very precise, with high precisions, to get centimeter level accuracy. So, if being those exposed, the risk here is of GPS and navigation systems being manipulated by attackers. Another thing I would like to highlight here is the fact that we found that worldwide, we have examples in South America, Scandinavia, Europe, and some other places. Oh, sorry, I just didn't finish that slide. Another specific technology that we found issues with, the ECDIS, the famous electronic chart display systems. In this case, this is the major electronic nautical chart provider, and multiple instances were running in AWS infrastructure, and they were using old versions of software and programming language like Apache, and versions ranging from 2.429 to 2.458, I guess, I remember, I think. And, well, that is definitely getting... It's an important issue in terms of exposure, and no visible authentication on some devices was found as well. Finally, the vessel tracking portals exposed. Here we found many interfaces, managing interfaces, including admin interfaces, and weak authentication mechanism as well. This slide is basically we found more than 10,000 NTRIP services exposed, and we just wanted to illustrate how this exposure was worldwide. These here are just 5 of them, and the locations they had. An interesting thing again now. When we were doing this, we found a couple of things, a couple of issues that we think we wouldn't have found if we hadn't used this methodology, only using OSINT. It's the fact that from the SNMP enterprise name, we could find that one Asian Navy was using a telco company on another country and on another continent, meaning that probably that was evidence of systematic maritime infrastructure spoofing, which was really, really interesting. Very basically, I just want to show you like some statistics of this big picture. Results and vulnerabilities found were geographically distributed in this way. Asia Pacific got at 42% of the exposure, Europe 28%, North America 18%, South America 5%, Australia 4%, and Africa just 3%. And finally, from me, recommendations. We could provide you with a bunch of recommendations, 100 and a huge list, but we just want to focus on the most successful ones and the most important ones. First one, reducing the attack surface. not everything has to be internet connected. Not everything has to be internet facing. Not everything has to be exposed. It's very important to have an inventory of everything we have exposed and reduce it. Second, these IT and OT sensors on the vessels. Here, since we have built this digitization on legacy infrastructure, you can see that, IT and OT sometimes is interconnected, and segmentation is key. So applying segmentation is of the utmost importance. And finally, applying some cybersecurity measures that would help remove most of the attack surface. Hardening and patching. And, I think that's a wrap from me, so the floor is yours. Kost.
Thank you. Yeah, I think it's also interesting to see how we've actually done it under the hood, because it's, of course, if you're watching this year, DEF CON, I think everybody is actually talking now about agentic AI and also about LLMs and MCPs. So please raise your hand if you heard from MCP or for something like that one. Anybody heard for it? Okay, I think I see I need to explain. So what we wanted to achieve with this, let's say, analysis is that we do it actually everything from the LLM, like a prompt itself, from the chat. So what that means? That means that we actually had to write somehow way that LLMs actually do most of the work. You just write the prompt and he does it everything, right? But what MCP means is once you, for example, get sick of just talking and chatting with the bot and oh, you are so smart, but please do something, right? Then you actually try to give him a hand, right? So he can do something himself, not that he just says, oh, this should be done this way, and so on, right? So with MCP, we actually implemented a lot of these tools which he can actually directly call. Please ignore this GDB, that's subject for another call, another talk. But the other ones are quite interesting because it can then actually do everything himself, of course. So, for example, you just write, let me just give you an example. On the video, you just write, okay, some of those prompts, and then it will do everything. So please enumerate all the maritime, right? And it will start doing everything from the start. So that means it will try to, in this one of the chats, it's trying to find all those maritime specific protocols, identify them, everything from there, and then you can query it a bit deeper. Also, you can navigate him to do something more, or he can actually analyze the results and do it himself, right? So this is all the essence of model context protocol, where you actually give him hands to do directly and not just talk, right? So this is just one of the examples. So this is the end game. How it's actually done, right, is you actually have human who is talking to MCP client, and then you make like MCP server for all these different tools. What we have done, we have actually wrote like MCP servers for these three ones here, but for these two, there is already MCP server, so there's no point in writing MCP server again because they exist. Okay, Zuma is more or less not working well so much, but these other ones are working, and idea was actually to write, and so everybody can do it. So even with everything will be released as open source, even these tools are like open source, so you can actually do it yourself, right? Another thing is, the question is why we wrote this way and not just, for example, hundreds of MCP servers for different APIs, because, for example, Spiderfoot and Bbot actually can talk to different ones. The answer is from the test, right? If you have a lot of MCP servers, and from experience, they get confused. So the better approach is actually to have few MCP servers and then actually have them talk with different APIs and get the results back. That's actually, you get the better results. And the other idea from the intelligence things, you probably already know if you're intelligence, you actually want to have at least like confidence from at least two different sources, right? Through two different tools. So that's why we actually have, as you can see, Bbot and Spiderfoot, and also like a shutdown and zoom eye from that point. And email sec is just a simple way how to check for email and DNS. So it's quite something that can be confirmed as well with the other ones. So that's how we actually done it. So that's way how we enable it. We can do it from that point of view. Why we have done it this way? It's because usually what LLMs usually people do is actually these boxes on the top. What they use it as anonymization, summarization, and unusual detection. But we wanted to give them a little bit more, right? So let him decide the scope. Let him decide the tools which he will use and the models. Let's say modules to use. And then, of course, you have the feedback loop where you can say, okay, please dig this deeper, it looks interesting, right? So you get much better results. And also, it's good because you can remove like obvious honeypots from the research as well. So you just remove those which looks like obvious honeypots and you just don't want to have them in the research as well. So it's kind of very standard one. And of course, since MCP is a standard way to write such hands for the LLM, that means that you can actually have it running on cloud, but also you can have it as a run as, for example, any different like Olama models, so you have self-hosted way to have all that data as well. So this shows how actually it looks like in different those clients. Of course, it should work with almost any. But of course, it depends on the implementation. So as you can see, there is only few functions, and this is the best way to actually write MCPs, because MCPs, from our experience, tend to lose if they have too much options. And if you look from the lessons learned, there's like models which just work out of the box once you write. So for example, if you're writing MCPs, these left just works out of the box. You don't have to do anything, but for some of them, you have to do extra work like Gamma, Llama, or Quen, older Quen's models. And also, we found out like there are a lot of clients, MCP clients, you can just use out of the box, and also we don't need extra work. For example, for MCP host, you have to increase the timeout, change the source, and so on. So actually, it's quite standard. There are some still things which needs to be done from on the model level, but the rest, really, if you want to do it, it's really just out of the box. It works. Of course, you still have the problems with security guards, right? So if you find too much like a malicious prompts, you will get these ones, but that's standard way of just writing the prompt and prompt engineering. I guess someone in the room is even better than me in writing the prompts. So it's just way how you craft your prompts so you can bypass these things. And also, let me just give you the tools how you can do it yourself. It's actually the whole this part which we wrote ourselves. Released at an open source license. If you go to the GitHub of Marlin Cyber, you will find all these tools which were missing. We had to write also like a few Spiderfoot modules. There are also like MCP servers which I mentioned. And you can actually scan yourself, of course, if you have permissions. If you have permissions, you can even like do active part, not just passive, and then you can get much better results. But let me give you how this looks like once you, for example, start doing for yourself. I'm just using this as a test as a scan me nmap work from fine folks from nmap because they allow scanning. So I don't want to bash anyone from the from the organizations. So you just say, come on, do the passive reconnaissance, and as you can see, there is a human in the loop if you want to like confirm every prompt. And then, of course, you can see all the queries he's doing, and then you can see the results. As you can see, it's really starting different scans with different tools, and also trying to expand different modules automatically. So you don't have to really put the hands in the pocket and just look how it done. Of course, if you spend a few days on automation, of course, right? And as you can see, it's trying to run all those like first bbot with different tool, with different preset, and then it tries to run with better flags and trying to decide on the results to run much more better results. So you can actually do it for your organization, and you will get, as you can see, complete log of what was being done. But also, once it's finished, it will actually write the report itself, right? So I know, at least I hate writing reports. I guess you also as well. So you know how actually that boring process is, but you can see it's actually doing like complete process from the beginning to the end. So as you can see, you get a report, you see everything what it have been found, but from the prompt you also get the other advantage, right? Not just, for example, if you look at the, of course, report, you will see complete report of scanme and map.org, but you will also get the logs, and the other thing is you will get, of course, what tools were being using, as you can see here, and all that stuff which is being done, right? But the best part is actually you can tell him, oh, please tell me what I need to fix right now. And as you can see, it will recommend the fixes. And later you can actually say, please write me the script to actually test myself on the system itself if it's being fixed and so on. So standard LLM stuff, right? So you can actually run on your system and try it out, right? As you can see, for example, in this case, it found SSH, so you can say, please provide the script to test it myself if it's okay. So yeah, if you are doing for the complete industry, I guess you want to do even a much bigger scope. You want to go with multi-agent with different contexts because there's too much data for single context. Then, but everything is ready to actually do it on the small level, but also on the big level. So the MCP servers are there. It depends how big the research you are doing you can do, right? So everything is ready, and of course, as you can see, you can then further do the queries and so on, everything inside the prompt, so you don't have to go outside at all. Yeah. So with this, we conclude our presentation. If there's any questions, we are here, but you can also like send us email or talk. We will be here today or tomorrow. So please, and thanks again for coming. And of course, I have some Croatian chocolate.